All right, let's get right into it. We've all had that moment, right? You build something awesome, you push it live, and then the traffic hits. And sometimes it hits like a tidal wave. Today, we're going to build your go-to guide for taming that traffic spike with one of the most powerful tools in the cloud, Azure autoscaling. So just imagine this for a second. Your app gets a shout out on a huge podcast, or that marketing campaign you launched just went totally viral. All of a sudden, you've got 10, maybe 100 times your normal traffic. What happens in that exact moment? Honestly, the answer to that question can make or break your entire application, and it's probably what keeps most of us engineers up at night. And this is the trap you fall into without a smart plan. I like to call it the traffic tightrope. Lean too far one way, and you're under-provisioned. Your site goes down, users see nothing but error messages, and that incredible opportunity you had, poof, it's gone. But if you lean too far the other way and over-provision just in case, well, now you're just burning money. You're paying for all these powerful servers that are just sitting around doing nothing 99% of the time. It's a lose-lose situation. But what if you didn't have to walk that tightrope at all? What if there was, a safety net? Well, in the cloud, that safety net has a name: elasticity. It's this amazing core idea that our infrastructure can just grow and shrink all on its own, perfectly adapting to whatever demand is thrown at it. And the actual mechanism that makes this elasticity happen is autoscaling. The idea is so simple, but it's a total game changer. Instead of a person staring at graphs and scrambling to add more servers, the system just does it for you. It automatically adds resources when things get busy, and this is just as important, it gets rid of them when things quiet down. So how does it actually work? Well, it's all based on this super simple 3-step loop that just runs over and over. First, the system monitors a metric, let's say, how busy the CPU is. Second, it's constantly asking, hey, has that metric crossed the line we drew in the sand? Are we over 80% busy? And finally, if the answer is yes, it triggers an action, like firing up a new server to help with the load. That's it. Monitor, check, trigger. Simple as that. Okay, so the theory is great, but let's see how this actually plays out in the real world, right? We're going to take that crazy traffic spike scenario and throw it at 4 of Azure's most popular services and see exactly how each one uses its autoscaling superpowers to handle the heat. Let's see them in action. And here are our 4 contenders. We've got VM scale sets for when you want total control over the whole machine. Then there's App Service, perfect for websites and APIs. We have AKS, the king of containers, and finally, Azure Functions for that sleek, serverless approach. Each one tackles scaling in a totally different way. So first up, we have VM scale sets. This is your classic old-school approach. When its metric gets triggered, it literally makes an exact copy of your entire virtual machine. The operating system, the software, the whole shebang. It gives you a ton of raw power and control, but think of it like building a new car from the ground up. It's powerful, but it's going to take a couple of minutes. Now, App Service works a little differently. See, it's a platform service, which means Azure is handling the OS part for you. So when it needs to scale, it's not copying the whole server. It's just adding a pre-warmed, ready-to-go copy of your application. It's way, way faster. And that's exactly why it's the go-to choice for web apps that need to be super responsive. Next up is the world of containers with AKS, and this is where things get really clever, because AKS basically has a 2-level response. Its first and fastest move is to spin up new pods, which are just lightweight copies of your app's container, on the servers it already has. Now, if that's not enough and the servers themselves start getting full, then it can take the second step and add brand new servers or nodes to the whole cluster. It's just incredibly flexible. And finally, we get to Azure Functions, the serverless approach. And honestly, this is where it feels like magic. A lot of the time with functions, you don't even configure scaling rules. The platform just watches for events, like someone calling your API, and it instantly provides the exact amount of power needed to run your code. You stop thinking about servers entirely and just focus on your code. Okay, so we know what the tools are, but having a powerful tool and actually using it wisely, well, those are 2 very different things. So now let's get into the strategy part. How do we scale smarter, not harder? It all comes down to picking the right triggers and avoiding one huge common pitfall. So that autoscale loop always starts with a metric. The most common one is CPU percentage. It's a pretty good all-around indicator of how hard your server is working. But you can get way smarter. My personal favorite is the HTTP queue length. Just think of it like this. It's the number of people waiting in line to use your app. If that line starts getting too long, that's the perfect signal that you need to open another register, or in our case, another server instance. All right, now for that big pitfall I mentioned. This is the one you really have to watch out for. It's a nasty thing called thrashing. It happens when your scaling rules are just way too sensitive. The system scales up for a tiny brief spike, then the load drops so it immediately scales back down, just in time for the next tiny spike. It just keeps bouncing up and down in this frantic, useless cycle that makes your app unstable and costs you money. And you can really see the difference. Thrashing looks like a panic attack on a chart, all these jagged, reactive spikes. Smart scaling, on the other hand, is this smooth, graceful curve that actually follows the real user demand. And the secret to getting from that chaotic graph to the calm one, it's a simple setting called a cooldown. It just tells the system, hey, after you make a change, just wait a few minutes. Let things settle down before you do anything else. So let's pull all of this together into a simple, actionable blueprint for you. These are the 4 key recommendations that will help you get auto-scaling right the first time and help you avoid all those common mistakes. Number 1, start simple. Just pick one metric like CPU usage and set a conservative rule, like scale up if CPU is over 75% for a full 10 minutes. Number 2, set that cooldown. After you scale out, force the system to wait at least 5, maybe 10 minutes before it does anything else. That's your defense against thrashing. 3, be way more careful about scaling in than scaling out. You don't want to get rid of a server right before another wave of users shows up. And number 4, and this is the most important one, you have to test it. Always load test your setup to see how it really behaves under pressure before your actual users do. And if you follow this blueprint, you can build systems that are tough, responsive, and incredibly efficient. You really can tame that traffic spike. But that brings us to the next big question, doesn't it? Now that your app can scale perfectly to handle any amount of demand, have you mastered the cost that comes along with